In this unit, we're going to be studying a topic called thermodynamics. And thermodynamics is a term used to study the following. Thermo stands for energy, or in this case, heat, and dynamics stands for movement. So during this unit, we're going to be studying the movement of energy or the movement of heat, thermodynamics. The other word is statics, and statics means not moving. But in this case, we're going to be studying thermodynamics, the movement of energy or heat. What we're going to be doing in this video, working through, is a heating curve for 100 grams of water. And when we begin with the 100 grams of water, we're going to be starting down in section A. And we're going to be starting with just the phase present of a solid. We're only going to be dealing with the solid. So down here, what I would like you to do is draw a cube. And you can picture this, because we're dealing with water, you can picture this as a solid piece of ice. The term that we use for water in the solid phase is ice. So you can picture this as a solid piece of ice. Now, ice can be any range of temperature up to 0 degrees Celsius. Once ice hits 0 degrees Celsius, a process begins that we'll talk about during section B. But it's possible to have a solid piece of ice at negative 10 degrees Celsius, or negative 20, or negative 50. You can have a range of temperatures that solid piece of ice can be. If we begin to give this ice energy, and that's what's happening through this whole process, we're going to be giving the water, H2O, energy. Now, if we're going this direction along the curve, we're going to be giving energy to the H2O. But if we're going the opposite direction, we would be taking energy away from the H2O. During this process of the curve, section A, the energy that is involved in this is called kinetic energy. And what we're going to place over here is this. Kinetic energy is related to the speed of the molecules. So you can think of the idea is the higher the speed of the molecules, the more kinetic energy it has. And in each one of these sections, section A, B, C, D, and E, we will either be having a change in temperature. This triangle stands for a change, or delta. And so we're either going to have a change in temperature or a change in phase. In this case, you can see the temperature would be changing. We might start at negative 20 here and then move up to only negative 10. So here we have a change in temperature. And later we will work on the equation that we're going to use during that section. So during this first part, you're starting with a complete solid piece of ice, water that's in the solid phase, and we're giving this ice energy. And as we give it energy, it begins to change temperature. Maybe we put it in on top of a stove or inside of an oven, or we put it outside and the sun is heating it up. It's absorbing energy and it's changing temperature. As it changes temperature, the molecules, even though these little H2O molecules are locked in place in a solid, they begin to jiggle and move faster and faster and faster. So it begins to have a higher kinetic energy. until finally it reaches right at this point. Right when the temperature hits 0 degrees Celsius, something starts to change. And what happens is now the phase that is present, is not just a solid, but it's a solid and liquid. The solid right at this point begins its transition into a liquid. The energy that's being absorbed by the water or the ice, the H2O, the energy that's being absorbed is called potential energy. When we think of potential energy, we're not thinking of the speed of the molecules, but instead we're thinking of the spacing of the molecules. So the energy that's being absorbed now is going into changing the spacing of the molecules. Notice during this process, when it's changing from a solid, all of a solid here, over here, all of a liquid, so all of a solid, all of a liquid, and during this process here, over here, more solid, less liquid, over here, more liquid, less solid. This is the transition from the solid to the liquid. When we're moving from the solid to the liquid, there is no temperature change. Notice it stays at 0 degrees Celsius. Instead, it's a change of phase. By change of phase, we mean moving from a solid to a liquid. We know what this change of phase is called when we start with a solid and end with a liquid. We call it melting. But we could also do the reverse and start with liquid and go pull energy out, and we would call it freezing. So we start with solid H2O that we call ice. We're increasing its temperature until finally, right at this point, we hit 0 degrees Celsius. And now it begins its process of changing from a solid into a liquid, in which the temperature doesn't change anymore. It's changing phase. When it's absorbing energy and changing from a solid to a liquid, we call it melting. If we were doing the reverse and going from liquid to solid, we'd call it freezing. And during this process, we are changing the potential energy of the molecules. We're changing the spacing of the molecules. Eventually, we will have all of a liquid. And when we are at all of a liquid, we can draw this kind of as a beaker, and then here, all liquid. Now the phase that is present is only a liquid. The solid is changed all into a liquid. And now, as you can see, the temperature starts rising again. And it rises from 0 all the way up to 100. In this, anytime you are giving it energy, the temperature is going to change. So we're going to have a change in temperature. Anytime we have a change in temperature, we're changing the kinetic energy, which is the speed of the molecules. So we're going to put kinetic here. And we continue to change the temperature. The molecules are moving faster and faster and faster in this liquid phase, until finally we reach this point right here where the temperature hits 100 degrees Celsius. All of a sudden, the temperature will stop rising, and what we will get during this section, section D, is we have our beaker sitting, or our pot of water, and we start getting bubbles that are forming on the bottom of that beaker or pot of water on the stove. So all of a sudden when we hit 100 degrees, the temperature stops changing and it sits there right at 100 as we change from a liquid to a gas. The phase that's present is both a liquid and a gas. And this time the energy is now going into changing the spacing of the molecules. So it is going in to change the potential energy, and we are also changing the phase. How do I know I'm changing the phase? Because I'm transitioning from a liquid into a gas. The term that we use for changing from a liquid to a gas is boiling. But if the energy is coming from the top, we call it evaporation. What I mean by that is when we place a pot of water on the stove, the energy is being heated coming from the bottom. So we call that boiling. But if we have a puddle outside and the sun is hitting the puddle, the energy is coming from the top, we call that evaporation. The reverse of that, changing from a gas back to a liquid, is called condensation. Condensation. Once all of the liquid has changed into a gas, now it's possible to take that gas and increase its temperature. Normally we don't do this. Normally we allow those water molecules that are in the gas phase to just fly away when we're boiling water on the stove. In this case, the phase present would be a gas. The energy that's being absorbed is going to be kinetic energy, and we are changing the temperature of the substance. Anytime we move from left to right along this curve, we are absorbing energy. Anytime we're moving from left to right, we are absorbing energy. We're moving from a lower state of energy to a higher state of energy. Any point we're going from left to right. The term that we use for absorbing energy in chemistry is endothermic. So what's happening anytime we move from left to right along this curve, it is an endothermic process. Therm, just like we talked about earlier, energy. Therm, endo means into. So we would say that melting is an endothermic process. We would say boiling and evaporation is an endothermic process. But we can not only absorb energy, we can also release energy. When we release energy, anytime we're going from the right side to the left side, any piece of this, we are releasing energy, giving energy away. We're moving from a higher state of energy to a lower state of energy by releasing energy. This process is called an exothermic process. Once again, that root word therm in there for energy, and then exo, releasing. So we would say that condensation is an exothermic process. We would say that freezing is an exothermic process. We're giving energy away because we're moving from a higher state of energy, liquid in this case, to a solid. This is the heating curve for H2O. Technically, water really refers to H2O in the liquid phase. We would call this ice, we would call this steam, and then this would be water. So technically, this would be a heating curve for 100 grams of, and maybe I'll change that to H2O because it's the water or the H2O molecules that are going through this. And when H2O is in this section, it's a liquid and we call it water. When it's in this section, it's a solid and we call it ice, and when it's in this section, it's a gas and we call it steam. I hope this helps with introducing the idea of an endothermic process absorbing energy and an exothermic process releasing energy.